Hello everyone, I hope you all are doing great. I welcome you all to this interesting series on system design. So in this video we'll discuss about the blob storage and a prime example that uses the blob storage, that is the AWS S3. And then in the demo we'll try to implement the internals of AWS S3. Okay, so let's begin with that. So let's first understand this with a simple example. What is AWS S3 and what is blob storage? So for that we can take an example of a warehouse. Let's take an example of Amazon's warehouse, where the Amazon stores from a small pin to a massive washing machines or the televisions or any other objects, right? Or whatever the products that we can see on Amazon's websites are all present physically in a warehouse, right? In a single warehouse where they are being transported back to our house when we orders any of those items, right? So that's for the physical storage. Now, for example, if you want to similarly store the digital products, like it can be a 4K video or a high resolution image. So if you want to store different kinds of digital files, then we have the option that is the AWS S3. So AWS S3 provides us with a storage option where we can store different digital items. That can be a video file, image, or a text file. Okay, so here how the storage works. So the storage is very simple. Here it's basically stored in the form of bytes. So whatever the bytes that are sent over the network, that is as it is stored inside the AWS S3 along with the metadata. So because of that byte storage, we call it as a blob storage, where we directly store the binary large objects. So here the binaries suggest the bytes which are stored, and the large objects can be anything, that can be image to a large video. So here S3 is one of the blob storage. So to that's a simple explanation for what is blob and how it is stored in the S3. So what is the metadata? So that is nothing but, again, whatever the information that we send along with an image or whatever the data which we store. For example, if we are storing an image, we may store the other information like the name, the resolution, or the location where it was taken. So all these are the metadata that are sent along with the image. So the metadata is stored separately, and the bytes of the actual object is stored separately. We'll see that in a demo how it is actually stored in S3. So we'll not be implementing exactly how S3 stores, but we'll try to mimic how it is done. Okay, so I hope you're able to understand what is a blob and what is a metadata of that. So here it is basically a network attached infinitely scalable file system. So S3 is nothing but network attached. Why do we call it as network attached? Because just by a single network call, we can get any object that is stored in our bucket. So basically we first, when we go to S3, we create a bucket that is inside that bucket we store our objects. So inside that we can store infinitely any number of objects that we want, and that can be easily retrievable over the network. So that is the reason we call it as a network attached infinitely scalable file system. So why that was invented, or why that was needed? Because traditionally how the data was stored, it was first written or printed on the paper, then it was stored in the files, and those files were stored in the cabinet. But as the data grows, the cabinet sizes grow, and we were unable to scale it further because of the space issue. So now, because of that, we went to a digital storage format like S3, where we can infinitely store the data without worrying about the scalability. So that's the reason for going with the S3. Next, what are the guarantees that are provided by the S3 or the blob storage? First of all, here it's the durability and availability, because here the data that is stored is on the physical disks. Okay, and when the data is stored on the disk, until or unless the disk is completely destroyed, our data is safe. Okay, so now here, coming back, how S3 provides us with the durability and availability. First, regarding the durability, as it is like famously said, S3 provides the 11 nines durability. That is, what does that mean? Like if we store any single object, like we can store 10 million objects in S3, and you can expect to lose a single object once every 10,000 years. Okay, one single object out of 10 million objects, and that too in every 10,000 years. So you can just think of how massively durable S3 is. Okay, so durability is nothing but the probability that your file will not be lost, corrupted, or destroyed. So that's the first guarantee that the S3 provides. And then next comes to the availability. So availability is nothing but how frequently or what percentage of time we can able to access our files stored on the S3. So that's also around 99.99%. That means our data is never lost, that is using durability, but over a year, you might experience a cumulative 52 minutes of downtime. That's a cumulative downtime. It's not a one-time downtime. And those 52 minutes is why we don't get 100% availability, but we get a 99.99% availability. Okay. So those are the two important guarantees provided by the S3. Now comes to the security part. Here we can take an example or an analogy of a hotel key card or a guest list, where with a hotel key card, what do we mean? The key card has a centralized added policies, like whoever customer this key card will be with, he will be having access to a particular room and to the gym or to the elevator, right? But if we go and that can be centrally managed, that can be, we can add more accessibilities or we can revoke the existing access, right? That can be centrally managed. But if we go with the guest list kind of accessibility, where we are putting the physical papers on each door and we are writing the names of the customer, so only the person's name present on that sheet are able to access that room. So even though if they have the key card, so that's a very vague or an inefficient way of implementing the security. So that's exactly how the AWS provides us with two options. That is, first one is IAM policy. So it acts like a hotel key card, where from centrally we can manage the access to the AWS S3 buckets. But if we consider the ACLs, that is the access control list. So these access control lists are attached directly to the bucket or the object, and ACL dictates which external account or users can read or write that specific file. So this is very specific to each object of the bucket, but IAM policies can be centrally managed. So that are more favorable and recommended way of implementing the security on the S3 objects or the bucket. Okay. So the next here is the interface. That is how we are able to access the S3 for the storage, retrieval, or destroying the object. So that is through the REST APIs. So we already know what is REST, that is representation state transfer. So we get simple APIs, that is put, get, delete, and list. Put will help us to upload the object, get will help us to get it, delete will help us to delete the destroy the object, and list will help us to list all the objects present in that S3 bucket. So that's how we able to interact with the S3. We can either directly upload the objects through the UI of the AWS, or we can also programmatically access through any of the server like backend applications. Okay. So we can take an example here, like for example, building an InstaSnap application that allows the users to upload the images. So here, how does that work? The user will upload an image, so the image will be sent over back to the server. Now the server will have the the client ID or the client secret, that is the access key and the client secret for that AWS S3 object. So let me explain you how does that works. So first of all, in AWS S3 we will create a user. So once the user is, let's say this is the user is created, that user is provided with the required policies, okay, like S3 read access, S3 write access, or S3 delete access. So all those access or the policies are attached to that user, and then we generate the access key and the secret key. Okay, so these access key and secret key are provided to that user. So that user can be system user or any user of that organization. So that access key and the secret key are used inside the application's backend server. So once the user uploads the image will be sent to the server. Now the server will use this access key and secret key, and then that using that it will send that over the REST API to the AWS S3, and the S3 will convert that, like it will store those bytes into the its storage along with the metadata, and similar thing will happen while getting back the data. Okay, so that's how the S3 works here. And post uploading into the S3 the data, it implements those guarantees. That is, first it will implement the data redundancy. That is nothing but it will duplicate synchronously that data into multiple availability zones that are geographically present in different geography. Okay, so that's how it provides a strong redundancy. Then it implements the consistency. So here the consistency is of type strong read after write consistency. That is, the moment the backend, the user application gets 200 status, that is, it gets the response from the S3, then you can be sure that in the next moment, when if you try to access that object, you will definitely going to get that object. So that's the strong read after write consistency. Okay, but if you take some other examples, like for example, if you upload a Insta post or a LinkedIn post, and if you open a new tab and just like try to access that post just immediately, you will find that sometimes you will not be able to get that post even though you got a success message in the another tab, because those works on an eventual consistency. They needs to still replicate those data to the different read replicas. Okay, so the moment when you try to read those posts in another tab, so that request may go to any of the nodes where the data is still not replicated, because here it is eventual consistency. The consistency is achieved eventually. Okay, but here with S3 we can get a strong read after write consistency. Okay, so I hope you are able to get this point. And the next here we have the serving the feed, that is how we get it using the get operation, and we also discuss about the security and the throughput. So that's again an important thing to discuss here. So regarding the throughput here, even let's say 10 millions of users log in at a point of time, and they want to try like access some object on S3 massively very efficiently handles all those 10 million requests. Okay, so that's again a very high throughput provided by the S3. So that's again one of the important guarantee provided by the S3. So that's a total architectural summary about the S3. And here we can say that whatever the files that are like any kind of files that are stored, that are larger, that cannot be stored in a traditional databases like SQL or NoSQL database, can be stored on S3. And most of the organization uses S3 as it is very cheap and infinitely scalable. Okay, next let's see a simple demo of how we can implement or create an S3 kind of storage, and we can read and write through it. Okay, so let's look at the demo. So in this demo, we will see how we can create an S3 storage like AWS, and then we'll see how a file upload works, how it is stored and how it is retrieved. So for this purpose, I will use the Docker containers. So here the Docker container will act as the storage disk where the files will get stored, and we will have multiple containers for the purpose of replication. Okay, so here let me create those Docker containers using Docker compose file. So Docker compose up in a detached mode. Okay, so there is a mistake in the command. Let me write it again. Docker compose up -d. Okay, so now this is going to create the containers. Okay, so the containers are created. Now these containers will act as the disk where the our files will get stored. So let us look at those containers. So these are the 3 containers that will act as a storage. Okay, so now let's run the demo. Python demo.py. Okay, so now let's focus on this. So here first of all we are checking whether all our storage containers are up and running all already. So let me just press enter. Okay, so in the step 1 here this is the file that we are going to upload, demo blob.bin. It's a bin file. The size of the file is this much, like 234 kilobytes, and the content type, the object key. So this is the key that we'll use to store this file in the S3 or in our demo. Okay, so against this key, this file will be stored in the storage. And expected chunk. So the moment if you observe when we start to upload a file, we already know what is the size of the file, and on that basis the server will calculate the number of chunks it needs to divide that file into. So I'll just come back to that in a moment. So here what is a blob? Blob is nothing but binary large object that is stored on the disk. So here this is the opaque byte object. So here the storage doesn't know that whether this is a image or this is a video. It just knows the bytes. Okay, so the file will be stored under this key. Let me press enter and let's go to the next step. Okay, so here in this step, here it will divide this file into these many chunks. So it will depend on the size of the file. If the size of the file is larger, the number of chunks will become larger. Now why it is divided into chunks? The reason is like let's say if the upload fails in the midway. Okay, so now when we retry it, we do not want to again upload the already existing chunks which we have already uploaded. So that is the reason first the file is divided into multiple chunks, and then it is uploaded chunk by chunk. Okay, so here after the chunks are divided, then each chunk's data is passed into a hash function, and a hash is generated. So this hash will help at the time of retrieval, where when we are retrieving back the data from the disk, again that chunk is passed into the hash function and a hash is retrieved, and that hash is compared with this existing hash. If it matches, then we are sure that we are retrieving the correct data. If there is some mismatch in the hash function on the hash value, then that means the data got corrupted. So that is the reason hash is generated and stored. So in the second step, the chunks are created and the hash function is generated. and there is a final hash is also calculated. That is nothing but the combination of the hash of all the chunks. Okay, so when finally the data is like created back, it is again passed into a hash function, and final hash is also calculated, and that is also checked. So after all these checks, only the data is retrieved back. Okay, so if there is any bit change, if even a one bit get flipped, then the data gets corrupted and the hash value gets changed. Okay, so that's how internally the storage works. Let me go to the next step now. So in this step, there are two files are generated, and that are the most important files. That is the metadata file and the manifest file. In the metadata file, we'll store all the information related to that, the file which we are uploading, like the labels, like what is the file type, when did we upload, custom tags, if the user has added few. Okay, like this, all the details about that file will be stored in the metadata file. Then again, we have another very important file, that is manifest file. So this is a file where all the details regarding the files are stored that will help during the retrieval time. If the manifest file is lost, then we are sure that our data is lost, because the manifest file will tell us how to retrieve back the data to the system. Because here we are indexing the data. Here this index represents the bytes that are stored on the disk. So according to the index, the bytes are retrieved back, and they are again joined and formed, and again the file is formed and sent us back. Because when the data is stored, even let's say if we are uploading two images, the images are same, but the name of the image is different. So here when we upload them on the storage, we will see that there are two objects, but internally it is going to store only once. Okay, the same object, the same file is stored only once, but we'll see it as a two objects, because at the end, as we know, here the storage, it only stores the bytes. It doesn't know anything about any details about the file. Okay, so that is the reason at the retrieval time, this manifest file is used to retrieve back the data. So here we have details like the key. First, this key will be used. According to this key, the chunks are retrieved back, they are joined, and then returned us back to the user whenever the get operation is done. Okay, so these are the two important files about the whatever the file that we have uploaded. In the next step, we'll see a put request. We are sending a file. So a raw put request having to this location. Okay, and here that is the response we have got back, and here the data was stored on the node 1. Okay, so if we go to node 1, we'll see some logs here. Okay, so get request was made initially, and then put request was made to store this data. So if we see the other two nodes, we don't have any data here yet. Now we'll see some logs in the node 2 and node 3 in the next step, where the replication will happen. That is the redundancy. Okay, so if I go to the next step here, so here in the step 5, we are seeing what is stored on the node 1's disk. So on the node 1, you can see it is only the bytes in 4 different chunks that got stored for that one file, and a manifest file is stored and a JSON file is stored. JSON file is nothing but the metadata. Two JSON files, one is manifest and one is metadata. Okay, so in the manifest file, these are the details got stored. That is a key, object hash, that is a complete whole files hash, and then each chunk and their hash. Okay, so all of these are stored in the manifest file. Then the metadata file has the metadata related to that file. So that's the insights we have here regarding the file 1 on the node 1. Let's go to the next step. So the next step is related to the replication. Now here, as we already know, the replication happens into 3 different availability zones that are present in 3 different regions. So that's we are trying to mimic here. Now if I go to the nodes, you will see that the node 2 and node 3 also got a put request. Now this put request was sent by the node 1 for the replication. Okay, we can also see the same in the node 3 also. Okay, so at this stage, our data has been replicated to other 2 regions also. So that's how we get the 11 nines durability that we already discussed across 3 physically separated availability zones. Okay, so 3 by 3 replica is confirmed, and this moment is where S3's 11 nines durability guarantees kicks in. Even if 2 and 3 nodes burn down due to some wars or calamity, the object survives on the 3rd one. Okay, let's go to the next step. So here in the step 7, we are retrieving back the data. So while retrieving back, again the integrity check happens. That is, the hash is computed back and it is checked against the existing hash that was stored in the manifest file. So both the integrity check is okay, so the data was not corrupted and the data was returned back to the user. Okay, so during the retrieval process, during the step 8, these are the steps happened. first the user will be retrieving back that data on the basis of a key. Okay, so the user will send a key. On the basis of the key, manifest is loaded. From the manifest, we will get the details about the chunks. Using the chunk details, we will retrieve the data from the disk, and all the chunks are reassembled, and then integrity check is done, and finally the data is returned back to the user. Okay, so deduplication. So here that we already discussed, uploading the exact same binary in a different key, that is two same images with a different name or different key. Because here chunks are stored by the SHA-256 hash, identical chunks are not written again on the disk. So if the chunks are same, they are written only once. Okay, so that's what we are trying to mimic here, where we are trying to upload the same bin file with some different name, and at the end you can see the blob files after the second upload is same. There are only 4 chunks. No new blob files are added because the file is same, only the key is different. But here we can see 2 different objects on the bucket. Okay, so that's all we needed to discuss here regarding how the S3 works. I'll be sharing you this the whole Docker and the other the main code. You can just rerun on your own machine, and you can play around this if you want to again look into these steps. Okay, so let's meet in the next video.